Okay, so we're looking today at the numeracy paper intermediate tier from November 21. Usual start, I've put down the grade boundaries for you to be mindful of. So it's out of, actually this one's out of 70 because it was the COVID one. So those aren't going to be right now. I hadn't thought of that. Anyway, so half marks would be 35. So the C grade's probably going to be about there. So this was one of the modified papers based on a more limited syllabus. Okay, we've come into the exam and in our heads, or in my head, I've got the metric to imperial equivalences. So I'm going to write those down straight away. 8 kilometres, no you don't. 8 kilometres is about 5 miles. 1 litre is about 1.75 pints. And what was the other one? Kilogram is about 2.2 pounds. Those are the ones you have to memorise. Any other equivalents they'll give you. 1.75 pints and 1 kilogram is 2.2 pounds. Okay, so I've written those down quickly while I've remembered them. I know that density is mass over volume. We might have to remember that triangle. I'm not going to bother with trig because it's a non-calculator paper. Speed is distance over time. Possible that one might come up. We're not going to need to worry about areas of circles, or unlikely, so I won't bother writing those ones down. So those are the ones that I'll remember. When we come later this week to learn about box and whisker diagrams, that's another quite a good one to jot down as soon as you get in. A box and whisker diagram always looks like this. I can't remember if this comes up in this paper actually. Okay, it's going to look like that. That's the minimum value. That's the maximum value. Yeah, I know you've done it before. And we're going to do it again this week too. So that's the maximum value. This line here is the lower quartile. That line there is the upper quartile. And the one that's within the box is the median. Okay, so that's also another one to quickly jot down. Right, so I've done that straight away now. As soon as the invigilator said you can turn over and start writing, I've emptied my brain of all that stuff that I've been trying to remember. And you may need to refer to it, you may not. So let's get cracking. So question 1. Dean went to the gym yesterday afternoon. The graph shows the distance Dean was from home during yesterday afternoon. So we can see here the vertical column, vertical axis is the distance from home. So when he's 0 kilometers from home, he's at home. And then as you move up, he's further away from home. And then across the bottom axis, the horizontal axis, you've got time. And I can see there that 2 of those large squares is an hour. So that's going to be 30 minutes and we can work out what we need to from there. Okay. So first question, how far away from home was Dean at 15:15? So we need to work out where 15:15 is on this axis. That point there would be 15:30. So 15 minutes would be halfway between there and there, which is here. So if I take that line vertically upwards, I can see that that's crossing at that point there, which is 2 little squares above 15. So now I've got to work out what each little square on this axis represents. And I'm going from 0 to 5 in 10 jumps. So each 2 squares will be 1 kilometer. So 1, 2, 3, 4, 5. So that's going to represent 16 kilometers. At what time did Dean arrive back home? So for the first part of the graph, he's moving away from home. Then he stays wherever he is before returning to home. So he's back at home at this point. And that point is 17:30. But what they're doing here now, just to test your ability to tell the time, is put it, rather than in 24-hour clock, in 12-hour clock. So 17:30 is 5:30 in the afternoon, which is PM. Circle the term below that best completes the statement. Looking at the travel graph, it is blank that Dean stopped for more than 10 minutes on the way to the gym. Okay, so looking at on the way to the gym, he's going to stop there because you know that he's stationary for the graph is flat when he's stationary. So if we look at that, we think that's going to be, it's about 15 minutes, isn't it? So looking at the travel graph, it is blank that Dean stopped for more. We're going to say very likely. Okay? It's not certain because he could be still moving in that 15 minutes, but not actually getting any further away or closer from home. So he's sort of kind of moving sideways, if you like. He's not changing. So it's not certain, but it's very likely. So you're either going to put a circle around very likely, or you're going to write very likely in there. Question 2. A water tank is filled every morning. The graph below shows the depth of water in the tank between 8 a.m. and 9 a.m. on Friday and Saturday. So check the axes. So the vertical axis tells you how deep the water is in millimeters, and the horizontal axis is once again measuring time. The black curve represents Saturday and the dotted curve represents Friday. What is the difference between the depth of water on Friday and on Saturday at 8:20 a.m.? So 8:20 a.m. is here. So we're looking for the difference at those 2 points. So we can see that there's a gap of 50 there, and each little square is going to be 5, 10, 15, 20, 25. Each little square is 5. So that's going to be 155. So it's going to be 55.
Yeah.
On both days, the tank filled with water to a depth of 360 millimeters. On which day did this happen more quickly? So it's either going to be Friday, Saturday, or the same for both days. So if it fills at 360, we can see that on both days it reaches that point at the same time. So it's the same for both days. Give a reason for your answer. Both curves reach 360 at 09 o'clock. Okay, so you just want to articulate that they both get there at the same point. Consider the time interval between 8:10 a.m. and 8:50 a.m. Okay, so we're looking at that region on the graph there. At what time was the depth of the water in the tank the same on both Friday and Saturday? So how am I going to know from the graphs where they are? It's where they cross. Good. Well done, Sal.
That's it.
All right. So it's not asking us what that depth is. It's asking us what that time is. So we're looking for that one there. I put papers on that table over there, Joseph. Don't matter, just grab them. So we're going 8:30, so 10 minutes. So each one of those is a minute, so 8:36. D. On which day did the water tank fill more quickly between 8:30 and 8:40? So we're looking between 8:30 and 8:40. So it's this part of the graph. How can I tell whether it's filled more quickly on the Friday or the Saturday in those regions, and why, Tom? Say it again. Larger range? So from the maximum to the minimum. How can you tell just by looking at the graph? Steeper, yeah. Boys? Okay, so we can tell that it fills more quickly on Saturday, and the reason is between those two intervals the graph is steeper. The Saturday graph, the black line, is steeper than the dotted line. So that's that one. The tank can hold water to a depth of 400 millimeters. On Saturday, at what time was the water in the tank half this depth? So it can hold water to 400, so half of that is going to be 200, which is there. So I'm using the vertical axis now for a 200 millimeter depth. At what time on Saturday? So I'm looking at the solid curve, so it's that point there. Which is going to be 8:35. Okay?
So have you got to like write on the line or not?
Sorry, Sally?
Have you got to write on the line?
No, it's not asking you to give a reason. So no, there's nothing you need to add to that. Okay, question 3. So this is the OCW question. So remember, that means you've got to be organised in how you lay this out. So the following advertisement appeared in the Dreig newsletter. Mr. Chen's guitar lessons. A single lesson costs £23. Pay in advance for 5 lessons and get 15% off the cost of these 5 lessons. Rowena has a guitar lesson with Mr. Chen. She then decides to pay in advance for a further 5 lessons. How much does Rowena pay in total for these 6 lessons? Okay, and then you've got 2/3 of a page for you to lay this out. So this is a non-calculator paper, so all those percentage techniques I was teaching you this morning you can't use here. This is where you do have to find the 10%, 5% and subtract it. So the first thing we need to do is work out what the total cost of those 5 lessons would be, and then take 15% off it. So cost of 5 lessons will be 23 times 5. So using whatever multiplication method you're comfortable with, we need to work out what that is. So 5 3s are 15, 2 5s are 10, and the 1 11. So 5 lessons cost £115. And what we then need to do is work out what 5% of that is. So for 15% reduction, %. So what would 10% of 115 be? 11. So £11.50 then, yeah? 5% would be half of that, which will be £5.75. So 15% be 527. So she's going to get a £17.25 discount. So that'll be £115 less £17.25. And again, whatever method you have of subtraction that works for you. So I need that to be 10, which means I need that to be 10 and then to become 9 and that to become 4. And that will become 14, so that will become, hang on. Boys! What have I done wrong here? Nothing. £97.75? Yeah. So the discounted lessons come to £97.75. The question is, how much does she pay in total for the 6? So she's got to pay the £23 for the first lesson and then £97.75 for the rest. So for the 6 lessons she pays 23 plus 97.75, 5, 7, 10, £120.75. Okay, so from the OCW point of view, you're just putting short statements explaining what you've done or what you're about to do. So it's not writing stories, it's just being organized. So first of all, I need to work out how much the 5 lessons would cost at full price, 23 times 5. Then I find out what 15% of that is and then subtract it. So the cost of the discounted lessons would then be £97.75, and then the 6 lessons would be that discounted cost plus the 23. Okay, David wants to learn to play the saxophone. Saxophone lessons will cost him a total of £300. He needs to pay a deposit to book the lessons. What percentage of the total cost of the lessons is the deposit? So this is one of the things we're doing this morning, writing something as a percentage of a total amount. So the first thing we would do is write it as a fraction. So the deposit would be 18 out of the total amount times 100. Okay, so that's the method. So there's 2 marks for this question. The method would be just for writing that, and then you've got to figure it out. Okay? So I don't know how Miss Rook taught you how to deal with fractions like that. Would you be cancelling out the zeros, or would you multiply the top first? You can't remember? Okay. Well, if we multiplied out the top, we'd have 1800 over 300. Then you can divide by 10, top and bottom, and you can divide by 10 again, top and bottom. So you end up with 18 over 3. 18 divided by 3 is 6. Okay, so again, it depends how either Mrs. John or Miss Rook taught you for that. So that's question 3. Question 4. Use this section of a map of Wales to answer this question. The map is drawn to scale. Okay, so that's telling us we can use our measuring instruments. Complete each of the following statements. The bearing of Llanbista from Rhyadr is blank. So, Llanbista from Rhyadr is where I am standing, and I want to measure the bearing to Llanbista. So if I draw in the line of sight, so I'm standing at Rhyadr, okay, so I'm standing at Rhyadr, I line the centre of my measurer at Rhyadr, and I line the 0 up with north, and I measure the turn as accurately as I can until I hit that straight line that I've drawn. Okay, and I get that to be 68. Okay, so I measure that to be 68. On the mark scheme, they would allow you plus or minus 2 degrees either side. So if you got 66 up to 70, you would probably earn the mark. However, I'm not going to get the mark for what I've written. Why aren't I going to get the mark for what I've written?
Oh, it needs to have a 0.
It needs to have a 0 because it's a 3-figure bearing. Okay, so the angle is 68, the bearing is that.
Yes.
The bearing of Bleddfa from Llanbista, so there's Llanbista, there's Bleddfa, is on that line, and I'm standing from Llanbista. So my measurer is going now to move to Llanbista. 0 lines up with north, and that is, I reckon, 118 degrees.
No.
That's already 3 figures, so you don't have to put the 0 in. Okay? B. Cumbellan is 2 miles from Llanidloes. Sioned travelled from Rhyadr to Crossgates in 30 minutes. Calculate your approximate average speed. Give your answer in miles per hour. You must show all your working. Right, there's a lot of information there. So, average speed, I think I wrote that down on the front. Yeah, speed is distance over time. So, speed is distance over time. And I know that she travelled that distance in 30 minutes, which is half an hour. So I need to find the distance between Rhyadr and Crossgates. Okay, so if I measure from Rhyadr to Crossgates, I've got the distance there of 4.5 centimetres. Okay, so Rhyadr to Crossgates is 4.5 centimetres. Now, I need to figure out what that is in miles in order to work out the speed in miles per hour. Now, the only information I'm given about the distances on the map is this distance here. It's telling me that in real life is 2 miles. In centimetres, it's 1 centimetre. Okay, so the scale of the map, I can use 1 centimetre is 2 miles. Okay? Because it's telling me here that distance in miles is 2 miles, and I can measure it because the map is drawn to scale. So 1 centimetre is 2 miles, so the distance between Rhyder and Crossgates is 4.5 centimetres. So to get from 1 centimetre to 4.5, I'm going to multiply by 4.5, which means I've got to do the same this side. So that means that the distance between Rhyder to Crossgates is 9 miles. Okay? So if she goes 9 miles in 30 minutes, how far is she going to go in an hour? 18 miles per hour. Okay? So her speed will be 18 miles per hour. 9 miles in 30 minutes. 18 miles in 1 hour. So there's a lot to think through for those 4 marks there. You're working with scale, you're working with speed. Everybody all right with that? Question 5. 3 different stores sell bananas. Fruit Court, 12 bananas for £1. Quick Fruit, 4 pence per 50 grams. Bach Market, 85 pence per kilo. You can assume that the mass of a banana in each of the stores is 100 grams. Sid needs to buy 24 bananas. Calculate how much Sid would pay in each of the stores. In which store would he be able to get 24 bananas for the least amount of money? So this is one of those best value questions, right? They've come up in every paper one that we've worked through so far. So it's worth you getting your head around this type of question. With a best value, you want to get the quantities the same so you can compare. Now they're helping you here because you're going to work out for each of these shops how much 24 bananas cost. So let's start with Fruit Co. 12 bananas cost £1. You want 24 bananas, so it's going to cost you £2. Quick Fruit. Okay, so in Quick Fruit it costs 4 pence for 50 grams, and it's telling you that 1 banana weighs 100 grams. So 1 banana in Quick Fruit is going to cost you 8 pence. Yeah, 4 pence for 50 grams, and a banana weighs 100 grams. So 1 banana costs 8 pence, so 24 bananas will be 24 times 8 using a method of your choice. 4 8s are 32, 2 8s are 16, and 3 19. So in Quick Fruit it'll cost you £1.92 for 24 bananas. And then in Bach Market, 85 pence per kilogram. And because they weigh 100 grams each, that's basically saying it's 85 pence for 10 bananas. So if it's 85 pence for 10 bananas, it's going to be £1.70 for 20 bananas. I lose the ability to write banana after writing it a few times.
I agree.
It just goes brrr. So £1.70 for 20 bananas. If 10 bananas cost 85 pence, one banana will be 8.5 pence. So 2 bananas would cost 17 pence. 4 bananas
Yeah, I know.
costs 17.34p. So I've got £1.70 for 20 and another 34 pence for the other 4. So in Bach Market,
Yeah, I know.
24 bananas, so £1.70 plus 34p will be £2.04.
Wait, in it,
Go on, Eve.
4 bananas is... Oh, no, I know.
Yeah, so one banana, so if 10 bananas cost 85, one will be 85 divided by 10, which is 8.5. Double that, you get 17. That would be 2 bananas.
Yeah.
Double it again, you get 34. Okay, so in which store will Sid get 24 bananas for the least amount of money? Quick fruit. So quick fruit, best value. All right, move on. Question 6. Right, Joe, come in. Shh. Boys, come on, keep focused. If you can't stay focused, go and get some air. Question 6. So the skeleton. Logan? Shh. So the skeleton of a dinosaur was found in Wyoming, USA in 2008. The skeleton is now on display in a shopping mall in Dubai. Here are some facts about this skeleton. It was transported 7,500 miles from Wyoming to Dubai. It's over 155 million years old. It's 80 feet long and 25 feet tall. How far was the skeleton transported? Give your answer in kilometers. Okay, so it's giving me the distance in miles, so I need to change miles into kilometers. I wrote it down when I got into the room. 8 kilometers is 5 miles. So 8 kilometers is 5 miles, and I know that this travelled 7,500 miles. So I've got to work out now what the scale factor is. How many times bigger than 5 7,500 is. So I'm going to do a little bus stop.
If you just want to know that 8 kilometres is 5 miles.
You've got to know it, yeah. Okay, so that's one of the ones. So these ones here, Tom, are the ones you've got to memorise. 8 kilometres is 5 miles. A litre is about 1.75 pints.
Yeah.
A kilo is about 2.2 pounds. Everything else they'll give you, but those ones, for one reason or another, they expect you to know. Okay, so 5 into 75. 5 into 7 goes once, remainder 2. 5 into 25 goes 5. So it's basically 1,500 times bigger, which means in kilometres I've got to multiply that by 1,500. So if I do 1,500 times 8, 0, 0, 5 eighths are 40, 1 8 is 8. You're looking at 12,000 kilometres.
I wish I had a school show that.
Okay. 6b. So here's one, Tom, that you don't have to learn, so they give it to you. 1 foot is about 30 centimetres. Calculate how long and how tall the skeleton is in metres. So I know that 1 foot is 30 centimetres, and I know the skeleton is 80 feet long. So to go from 1 foot to 80 foot, I'm going to multiply by 8, E. So I need to multiply this by 80. 3 8 to 24, followed by 2 zeros. So in centimetres, it's 2,400. In metres, I divide by 100, because there's 100 centimetres in a metre, so it's going to be about 24 metres long. And then for the height, 1 foot is about 30 centimetres, and the skeleton is 25 feet tall. So I got to times by 25. So I got to times this by 25. So 3 lots of 25. 3 lots of 25 is 75 with a 0. So that's going to be 750 centimetres, which is going to be 7.5 metres. Divide by 100 to turn the centimetres into metres. Okay, they're really hammering this dinosaur question. Assume the skeleton has been transported complete in one crate. The crate was in the shape of a cuboid. Which would be the best estimate of the volume of the crate? Circle your answer. Okay, so let's shove this dinosaur in a crate. Okay, so I'm going to box him up. So its length was 80.
80 times.
Its height was 25. And we need to estimate how wide that box with that crate was going to be. Sorry, for B? What do you want to know, Will?
8 times 3.
Yes, you do 8 times 3 is 24. And then you got 2 zeros. So it's 2,400 centimetres. And then you divide it by 100 because you want the answer in metres. So it's 24, yeah. Okay. So back to our box. We're estimating here the volume of the crate. So if we say, we know that it's 80 long, we know it's 25 high, let's make it 10 deep, just because that's a nice easy number to multiply by. Okay, so to work out the...
Why don't you just do 8 by 25 and instead of doing a cube, instead of doing a square, do it as a cube, so it's the same as y, it's 25y.
So you want to do 25 by 25 by 80?
No, if you do 8 by 25, so you've got 2,000.
Yeah.
And then instead of it being 2,000 square, I'm going to do 2,000 cube. Because that's balanced.
As long as you get the right one. Okay, so 8 times 25 is 200. Okay, so the volume so we can do that. Okay? 8 times 25 is 200. And then we got the extra 0. And then we got the extra 0. Boys, as these get progressively harder, it's important that we concentrate. If you don't want to concentrate, just leave. Okay? So to go back to explaining this, right, Joseph?
Yeah.
It's telling me that the dinosaur is 80 meters long. It's telling me the dinosaur is 25 meters tall. And that means that that crate has to have those dimensions. Just to make it easy then, because it's not telling us how wide this crate is going to be. So I'm saying it's 10 meters, because multiplying by 10 is easy. So to work out the volume, it's length times width times height. So I've done 80 times 25 times 10. 8 lots of 25 is 200. Add a 0 because we're doing 80. And then I'm multiplying that by 10. So I end up with that many zeros. Which means it's that in square feet.
Do you get a calculator for this?
No. Last question on dinosaurs then. Which of the following is 155 million written in standard form? So I got 155 million. Okay? And I need to turn that, I need to turn that into standard form. So where does the decimal point have to live or end up for it to be in standard form? It's going to be 1 point something, yeah? It's going to be between 1 and 10. So it's definitely not that one. It's definitely not that one. So I got a choice of 3. Now, when we did this the other week, I said, look, it depends how you were taught. The way that I would teach standard form is I would write the little powers above. So the first column would be 10 to the 0, 10 to the 1, 10 squared, 10 cubed, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7, 10 to the 8. Okay, so to get that decimal point there, where you want it to be, it's going to be 1.55 times 10 to the 8. If you do it by moving the decimal point, that's where the decimal point starts, and you've got to move it once, twice, 3, 4, 5, 6, 7, 8. Sorry?
I thought because I thought it was like how many numbers are. Oh, actually you're right. I know you're right.
So why did you move it there?
Yeah.
So again, what?
I just gave you one.
Because the number part of it has to be between 1 and 9.99999. Okay? So it's got to be 1.55.
Do you move it like before, no, after the first number? Just do that. No, well, you count from the back. Yeah.
So
You go to the first number.
yes. So between the 1 and the 5. Because that's bigger than 10, yeah? Okay, good. Okay, question 7. Boys, I want to get through this. Guys? Okay, I don't want to be talking loud. My voice is a bit shredded today. Tom? Thanks. Okay, number 7. Penystrid is a mountain village. The daily rainfall for April 2021 is given in the table below. Okay, so let's just check we understand what's happening here. So the daily rainfall in this row here that my pen is highlighting is telling me that there are 11 days in April where the rainfall was between 6 and 12 millimetres, including 6, excluding 12. Okay? Wesley asks, during April 2021, on how many days did it not rain in Pennystrad? Explain why it is not possible to answer Wesley's question using the table shown above. Okay, so I know there were 15 days where the rainfall was between 0 and 6. But because the data's grouped, I got no way of telling whether any of those days was exactly 0 or not. Okay, so it's not possible because the data has been grouped.
Yeah, surely 24 is the highest, and then,
Because the data has been.
and then there's less than 30 on the columns. So.
Yeah, but you don't know. It could have rained every day, or it might have been, those 15 days could have had no rain at all. Yeah, you can't tell because the data has been grouped. Okay, calculate an estimate for the mean daily rainfall. So this is what we were doing last week, yeah? So the first thing I need to do, because it's been grouped, is do what? Mid-value. Okay, Sally? So the mid-value, what's going to be the mid-value for the first group? 3, then
8.
9, then 15, and then 19, is that? 21. Okay, then we need to work out what the totals are. So we multiply them together. 3 15s are 45, 99, 45, 21. Add those up, and the examiner gets this whole page, okay? So even though you've got this big gap down here to work this out, you can do the maths up there if that's where you want to do it. Okay, so we add these up, we get 10
So what does that MV at the top mean? Sorry.
mid-value, midpoint, MP if you prefer. And then we got 10, 19, 21. So calculate an estimate for the daily mean value. So the total will be 210. The count will be the number of days in April, 30. So the mean will be total divided by the count, divided by 10, divided by 10, and then 21 divided by 3 is 7 millimetres. Okay, so that's what we were doing last week. It's just unusually, it's on a non-calculator paper, but the maths is just easier when it's that way around. So that's good. B, Glanwen is a different village. During the first 25 days of April, the mean daily rainfall was 4.4 millimetres. It did not rain in Glanwen during the last 5 days of April. Calculate the mean daily rainfall in Glanwen for April. So to work out the mean daily rainfall in April, I need to know what the total rainfall is going to be. Okay? So I'm going to work out what the total rainfall is going to be, and then divide it by 30, because there are 30 days in April. Okay? So I know that in the first 25 the mean was 4.4. How can I think back to what we were doing last week on reversing the mean? If I know in 25 days the mean is 4.4, what do I do to work out the total? Okay, so the mean is the total divided by the count. I know the count is 25. I know the mean is 4.4. I want to get that. So you do the opposite, you times, yeah? So the total will be 4.4 times 25. So you've got to use whatever method you're comfortable with for multiplying a 2-digit by a 2-digit number. Okay? Again, it depends on what Mrs. John, Mrs. Rook taught you. I'll do it this way, because this seems to be the most popular way people like these days. Okay, so you do your little block, 44 on the top, 25 going down, and then you fill in the gaps. So 4 times 2 is 8, which we have to write as 0.8. 4 times 5 is 20. 4 times 2 is 8. 4 times 5 is 20. And then you add up your diagonals. So you've got 0, 10, 11, 1. So that's going to be 1, 1, 1. And where's the decimal point going to go? Because we had a decimal point in there. After the... There, yeah? So the total rainfall in those 25 days is 111 millimetres. It did not rain at all in the last 5 days of April. So I've got no more rain to add to that. But I've now got to divide it by 30 because there are now 30 days over the whole month. So the mean for the 30 days will be 111 divided by 30, which is the same as 11.1 divided by 3. Okay, just dividing by 10. So 3 into 1 doesn't go. 3 into 11 goes 3 times. Remainder 2.
So it's going to shut down.
Thank you.
Why do you like fun of me?
Oh, yeah. Was that nice? Wait, so what was the answer to this shoe?
Hang on. No, I got wrong here. Okay, boys, Logan. Will, I got wrong. Okay, so I've made a mistake. And I made a mistake here with the multiplying. 8 and 2 is 10, not 11. Okay, so it's 110, not 111. Okay? Guys? So, going back to my division, I got 3 into 11 goes 3 times, remainder 2. 3 into 20 goes 6, remainder 2. And this is just going to keep going. I want to give my answer to 3 significant figures, so I can stop after that point there. The 3 most significant figures are the 3, because it's a unit, then the 0.66. So 3.66 millimeters to 3 significant figures. All right? Okay, we'll take a break. Okay, question 8. Sarah makes and sells handmade chocolates. She makes boxes for her chocolates in the shape of a tetrahedron. Sarah uses thin carton to make each box. The length of each edge of the box is 5 centimetres. What is the total length of the edges of one box? So you've got to know what shape a tetrahedron is.
I don't have any idea what that is.
So a tetrahedron is a triangular based pyramid. Okay, so it looks like this. Okay, so it's got, rather than, so a square based pyramid is the sort of the one you,
So you're like expected to know that exam.
so you're expected to know what a tetrahedron is, yeah. So a square based one would have a square bottom, triangular one is like that. So the total length of the edges of one box, so we've got 1, 2, 3, 4, 5, 6 edges, and the length of each edge is 5 centimetres. So the total length of the edges would be 30 centimetres. So that's one of those questions that if you didn't know what a tetrahedron was, you wouldn't be able to answer that. But it's only worth 1 mark and you could take a guess.
Yeah.
Okay. Each box contains 4 chocolates. Each chocolate costs Sarah 7 pence to make. She can make 25 boxes from thin card for 50p. She makes just enough chocolates and boxes to sell 150 boxes. Sarah makes 20% profit from selling all 150 boxes of chocolates. How much profit does she make? So what we need to do here is, first of all, work out if she's going to sell 150 boxes, how much the 150 boxes are going to cost and how much the chocolates are going to cost that will fit in them. Okay? So if she's going to make 150 boxes and each box contains 4 chocolates, then the number of chocolates will be 150 lots of 4, which double it, you get 300, double it again, 600 chocks. Each cost 7 pence to make. So you're going to get 7 sixes of 42. So the chocolates are going to cost her £42 to make. Then we've got to cost the boxes. She can make 25 boxes from thin card for 50 pence. So how many lots of 25 is she going to need for 150? So amount of card needed. So 25, 50, so 4 for 100 and another 2. So it'll be 6 lots of 50p, which is 300p, which is £3. So the total is going to cost her to make that is going to be £45. Now she's going to make 20% profit. So 10% need to find 20%. So 10% would be £4.50. So 20% would be £9. So she makes £9 profit. If the question asked how much does she sell them for, then you would add that £9 onto the 45. But this is just asking for the amount of profit, yeah? So the profit is £9. Question 9. This is something we're going to be looking at next week, I think. A fast food restaurant has staff name badges in the shape of a star. Each badge has a pin across the back as shown in the diagram. Members of staff choose the size of badge they want to wear. The badges are mathematically similar. That word similar in maths is a trigger point. Basically it means every measurement in the larger one is a scale factor of the sizes in the smaller one. So everything's been multiplied by the same value. Okay? The length of the pin on the larger badge is 3.9. Calculate the height of the larger badge and the length of the pin on the smaller badge. So in order to work out the height, I'm going to take that height and multiply it by the scale factor. In order to work out that length, I'm going to take that length and divide by the scale factor because I'm shrinking it down. In order to work out what the scale factor is, I use a pair of corresponding sides that I know. Okay? So the scale factor would be 3 divided by 2, which is 1.5. So everything in the bigger shape is 1.5 times bigger than the smaller shape. So the height of the larger one would be 4.2 times 1.5. So you could either do that by multiplying or half it and add it on. Let's do it by multiplying. Four, 2, 1, 5. So 2 times 1 is 2. 2 times 5 is 10. 1, 4 is 4. 4, 5 is 20. Add up your diagonals. So it's 630. There's two numbers, 2 digits after the decimal point in the multiplication. So there's going to be 2 digits after the decimal point in the answer. So it's going to be 6.3 centimeters. To get the length of the pin, we're shrinking, so we're dividing. So it'll be 3.9 divided by 1.5. Which is going to be the same as 39 divided by 15. So if we think about 39 divided by 15, 15 into 39 goes twice. Remainder 9. And then 15 into 90 is going to be 15, double it is 30. So if you think we got 15, 30, 45, 60, 75, 96. So it's going to be 2.6. Okay, so the trigger there is that word similar. Once you see that, you're looking for a scale factor. And the last question, which is what we're going to be looking at Thursday and Friday this week, cumulative frequency. So Bethan works as an office manager at the medical centre. Last Monday, 60 patients each had an appointment with the doctor. Bethan recorded how long each patient's appointment lasted. The results are given in the table below. So there were 4 patients whose appointment lasted between 0 and 4 minutes. 24 patients, the appointment lasted between 4 and 8 and so on. So the cumulative frequency table just takes a running total of that. So there were nobody weighted less than 0. 4 people weighted less than 4. Less than 8 takes you to there, so it's those 4 and those 24, making 28. Less than 12 is going to be the 28 plus another 18, so that's going to be 46. Then less than 16 is the sum to there, which is 46 and 6, 52, 54, and 54 and 6 gives you 60. Okay, and as I said, we'll practice that later this week. On the graph paper below, draw a cumulative frequency diagram to show this information. So less than 0 is 0. Less than 4, so the time is less than 4, so 2 squares is 1, 1, 2, 3, 4. Less than 4 is 4. Going up, it's going up, 1 square is a unit. Less than 8 is 28. So less than 8 is 28. Less than 12 is 46. So 10, 46, 11, 12. Less than 16 is 52. 15, 16, 2. Less than 20 is 54. And less than 24 is 60. So the points look like that. And then to join them, you can either join them with a curve or you can join them with a ruler. Does that. Each patient is given 10 minutes for their appointment. Use your graph to give the best estimate for the number of appointments that lasted longer than 10 minutes. So when you read off a cumulative frequency graph, your reading is less than, okay, because that's what you've plotted. So if we look at 10 minutes there, if we read up 10 minutes, and you read across, that tells you that there were 34 people who got less than 10 minutes. So if you want to work out how many got more than 10 minutes, it's the gap between 60 and 34. 34 people waited less than 10 minutes, so longer than 10 minutes would be 60, take away 34, which is 26. Of the patients seen last Monday, what percentage spent longer than 20 minutes with the doctor? So 20 minutes is 54. So 54 spent less. So 6 patients spent longer. And as a percentage, that would be 6 out of all of the patients, which is 60, times 100. So that would be 600 divided by 60, which would be 60 divided by 6, 10%. The median length of appointments last Tuesday was 11.5 minutes. How much shorter was the median length of appointments on Monday? So I got 60 patients. Median is going to be in the middle. I'm looking for 30 patients. So now I'm going up to 30 on the cumulative frequency and reading in the opposite direction. So this is my median. I'm reading down. 9.5 on Monday. Okay, so median on Monday was 9.5 minutes. So So how much shorter was it? It was 2 minutes shorter. 9.5, 10.5, 11. And then the final question. Bethan is considering changing the time given for each patient's appointment to 12 minutes. She would set a target of 80% of patient appointments taking less than or equal to 12 minutes. Would this target have been met last Monday? Okay, so 80% of the appointments, so 80% of 60. So 10% would be 6. So 80% would be 6 eighths, 48 patients needed to meet target. So we're looking for 48 patients. Did 48 patients take less than 12 minutes? So 12 minutes, 10, 11, 12 is there. So if we read across, we get 46. So on Monday, 46 patients met the target. Only 46 met target. So no. I've rushed through that a bit. But as I said, it is work that we're gonna be practicing quite a bit on later this week. All right.